to get a kick from me. Oh, lucky. Today, no. Okay, today I can record it. So usually if you got kicked out, don't panic. All right, that is because of the recording. So it say I must kick you out in order to record the section. So I don't know why. All right, now let's begin today's class. Okay, chapter 2. So equations of linear motions. Equations of linear motion is used to describe the motions of an object that is moving with constant acceleration. Now this is the rules. If object is not moving with constant acceleration, then you cannot apply these 4 equations. Okay, so there are 2 possibilities. The other one I will show you after this. So first, we are going to focus on constant acceleration. So constant acceleration, okay, the equation is obtained by combining the ideas of a displacement, velocity, and acceleration. So you have these 3 items in an equations. So consider an object that has an initial velocity u. So initial velocity, the symbol, we call it u. And then time is a t with a constant accelerations a. And the final velocity, we call it v. Okay, so we have a 4 variable in equations. So whenever you are going to solve an equation that involve linear motion, make sure you look for these 4 items in the equations. So u, v, s, a. These 4, they are vector, and the last one is a scalar quantity, which is time. So these 5 variables. So if you have 3 variables, then you will be able to find the 4th variables. Okay, so usually we have 4 variables in an equations. Okay, now let's go back to the derivations. So how to derive it? Actually, it's coming from a graph. So you plot a graph of a velocity against time. So if you recall the things that we learned in our previous lecture, whenever you have a VT graph, then a gradient, okay, gradients of the graph, it represents acceleration. And then area under the graph, it represents displacement. So basically, you can still use this concept in deriving the equation. Just that now, instead of value, you use variable. Okay, so final final velocity is v, initial velocity is u, and then the time along x-axis is t. All right, so from here you can get v equals to u plus at. Okay, because you obtained it from the gradient, a equals to v minus u divided by t minus 0. Rearrange the equations, you obtain the first linear motion equation, v equals to u plus at. And then if you calculate the area by using the equations of trapezium, then you obtain the second equation, s equals to 1 over 2 u plus vt. Now, when you combine equations 2 and equations 3, you sub equations 1 into equations 2, then you obtain the third equation, s equals to ut plus 1 over 2 at squared. Now, you don't have to know how to derive it. Okay, but sometimes if the questions give you a diagram, it asks you to find the equations, then at least you have to know. Okay, the gradient represents accelerations, and then a shaded area, the area under the graph, represents displacement. Okay, and then the last one is also coming from equations 1 and 2. So you rearrange the equations and then you combine them, obtains v squared equals to u squared plus 2as. Okay, now if you notice, if you look at these 4 equations carefully, first equations, okay, you have v, u, a, t. Okay, so these equations don't have s. The second equation, you have s, okay, and then u, v, t. A is missing. Okay, and then the third equation, you have s, u, t, and a. V is missing. And then the last one, you have v, u, a, s. So t is missing. So for instance, out of the 5 variables that I asked you to take note just now, okay, every equation contains at least 4 of them. So that is how you choose which equations to use in the question. All right, you try to list out the information, see which 4 equations you have. But most of the times, the question will give you 3 pieces of information. Okay, and then you need to find the 4th information. So you just compare the equations given and the equations that you want to find and the information that you want to find. See which equations to use out of these 4. All right, that is a technique in solving questions in chapter 2. Okay, so kamu list out maklumat dulu. Tengok U, V, A, S, T. Kamu ada maklumat apa? Biasanya soalan akan bagi kamu 3. Okay, 3 info akan diberi. 3 info will be given. And then you need to find the 4th one, okay, the 4th info. So, okay, you look at these 4 variables and then you try to compare with these 4 equations. See which one can be used, because every equations contain at least 4 information, 4 variables. All right, just one missing. Equation 1, S missing. Equations 2, A missing. Equations 3, V missing. Equations 4, T missing. So you will have all this information. All right, you will have the other 4 informations in an equation. So you just compare. Okay, you compare the informations that you found from the questions and then with the equations. That is the technique in solving questions. So projectile motions. Now projectile motions, now they put a theta equals to 0 degree, which is a projectile motion, 0 horizontal projectile motions, and also theta equals to 90 degree under the this subtopic, projectile motion subtopic. So when theta equals to 90 degree, it is a free fall motions. Okay, the object is launched at 90 degree, it means. So you throw something upwards. For example, this is an object, you throw it upwards and then it falls back along the same path. So this is free fall. Okay, this is free fall. So free fall means no external force. All right, no external force. The moment you throw an object and the object leave your hand, then the object is already in the free fall motion. It already undergoes free fall motions. Because it leave your hand, now it moves freely without any external force. As long as you're still holding it, then that's not free fall, because you are the one that give it external force. Okay, you're the one that give it external force. So the moment you throw something up or the moment you drop it, then the object will undergo free fall, right? Because of no external force already. Now it moves freely. So a free fall diagram, a free falling body is defined as the vertical motions of a body at a constant acceleration, okay, which is a g under gravitational field without air resistance. So this is the first assumptions that we made. Okay, no air resistance. Now, in reality, or when you proceed to a university, you have to take into consideration the effect from air resistance. But now we are still learning the basic of a motion. Therefore, we assume there's no air resistance. All right? Don't go to university and tell everyone, no, there's no air resistance. Okay, that is wrong. Okay, you have to take into considerations the effects from air resistance. But since now we are looking at basic, to make it easier for us, we assume there's no air resistance. All right. So free falling body, okay, is defined as the vertical motions of a body at a constant acceleration without air resistance. So in Earth gravitational field, the constant acceleration, okay, known as the accelerations due to gravity, or the gravitational accelerations. Okay, so the constant accelerations, we call it gravitational acceleration, or sometimes it's known as accelerations due to gravity. So there are a few terms that we use to describe it. Okay, accelerations due to gravity or gravitational accelerations. They are all refers to constant acceleration. The values of g is 9.81. Now remember, this g is just magnitude without direction. Okay, g just represent magnitude. And the direction of this g is always pointing towards the earth. So we say downwards. So in this case, what can we say? Now, when you combine these two statements together, actually we obtain a relationship called A equals to negative G. Okay, A equals to negative G. When you combine the two statements together. So remember, when you want to apply the equation from a previous slide, okay, previous page, this 4 equation. Now this 4 equation, it uses A. Okay, you have A, you have A, you have A. When you want to apply it in a free fall motion, then you need to substitute A equals to negative G. Okay, of course, with a condition, there's no external force. If there's external force, then A is no longer equals to negative G. You have to look at what happened now. I give you an example. Okay, so now, just now we say something moving in a straight line. You throw something up, okay, and then it fall down. So in this case, because there's no external force, therefore we say A equals to negative G. Now, if you launch a rocket, okay, you launch a rocket. So now this rocket is moving upward because of the burning fuel. Okay, you burn fuel inside it. So it is moving with external force. All right, it is moving with external force, and therefore we cannot say A equals to negative G. In this case, a is not equal to negative g. You have to look at what is the acceleration. It could be a positive value. It could be a negative value. All right, but it is not equal to g. Why? Because of the burning fuel. You burn the fuel inside the rocket, and therefore it can goes upward. Okay, it can move upwards. Now, when you throw object, okay, there's nothing. Okay, the moment it leaves your hand, there's no external force, there's no burning fuel, nothing inside it. Okay, therefore it moves freely, and then we can conclude A equals to negative G. So make sure you read the questions carefully and you understand which situations you're looking at. So free fall usually refers to the case where there is no external force. All right, but when it comes to motion, if you look at the motions in general, then you could have a G situations. Okay, A not equals to G situations. So remember, A equals to negative G only applies if object is a free falling body. Okay, free falling body means no external force. So linear motion in general, we use the four equations that we derived just now. V equals to U plus AT, V square equals to U square plus 2AS, S equals to UT plus 1 over 2AT square, S equals to half bracket U plus VT. For a free falling body, you can rewrite the equations, okay, as a V equals to U. Now, A, you sub it as negative G, so minus GT. Now, most of the time, I don't encourage my students to use this set of the free falling body equations. Okay, I always encourage them just memorize this four to make your life easier. You don't have to memorize that much equations. Okay, so V square equals to U square, okay, minus 2GS. So A again becomes a negative G. Next one, S equals to UT. Now, A again, so it becomes minus 1 over 2 GT squared. So the last one, there's no G, therefore you can just write it as equals to 1 over 2 U plus VT. Right, so the only things that is different between these two set of equation is that A, you sub it as a negative G. All right, A, you sub it as a negative G. So next one, the sign conventions. So this is the sign conventions.
Madam,
Yes.
what happen kalau macam kita buat S equal to UT minus 1 to AT power 2?
Oh, if you write it as a S equals to UT minus 1 over 2 AT squared, if you sub the value correctly, then that is still acceptable. But if you sub it as a wrong value, then you're going to get 0 mark, including the equation. Okay, so that's why usually I ask my students to memorize this set of equations only, rather than you go to memorize both set and then you make yourself confused. Okay, so if you write the equations correct, and then you sub it with the wrong value, for example, you still get marks for equation. But if you get a wrong equation, for example, you say you write S equals to UT minus 1 over 2 AT squared. Now this equation is wrong, okay, because the original equation should come with a plus sign. So in that case, if you sub A as negative 9.8 again, for example, you say, okay, UT minus 1 over 2 negative 9.81 T squared, then this is wrong. Then you're going to get 0 mark, okay, including the equation. No marks for the equation because you use the wrong sign. So is that clear?
Yes, madam.
All right, cool. So remember, don't memorize this one. Okay, this is wrong. Okay, so this sign convention is only for acceleration. Therefore, you have a plus sign if it's going up, and then now actually I don't like this sign conventions. Okay, for me actually it's wrong. So this one we are going to skip it. Let's go to the notes that I give you. All right, so this sign convention is actually only correct for velocity. Okay, it's only applicable for velocity. But now we are looking at the acceleration. Therefore, I don't encourage you to look at this. I want you to just cancel it out. And now we go to the notes that I give you. How to determine the sign convention. Okay, how to determine the sign convention for the first thing, displacement, S. The second thing, velocity. And then the last one is the acceleration. So for horizontal motions, now when it comes to motions, we have to look at them in terms of a horizontal and a vertical component. If you have something moving along an X component, then it's easy. It's a 1D question. You just look at the horizontal motions column. If you have a free falling diagram, then you just look at the vertical motion. If you have a projectile motion, then you have to look at both of them, right? Now let's just look at the sign convention in general first. How are we going to determine the sign convention for displacement? So displacement, our reference is actually its original positions of the object. Okay, so for example, now you have an object. This is a car. So this is its original position. Okay, so this is the original position. So we are going to take this as a reference line. So if object move to the right, then we say it has positive S, regardless of its directions of motion. So for example, now I have a car moving to the right, and now it's located at here. Okay, it reaches this position. So at this position, it has positive S. Okay, and then it keep moving. When it reaches here, okay, it's still going to the right, so it's a positive S. But what if my object is turning back here? Okay, now it makes a U-turn. It wants to go back. Okay, now because this object is still located on the right-hand side of the original position, okay, this is our original position. So even though it's moving to the left, okay, this is to the right, this is to the left, it is still positive S. Okay, that is because of the location. So for displacement, you look at the location of the object. If it is on the right-hand side, it doesn't matter whether it is going to the left or going to the right. You are going to use positive S. Okay? So if it is going to the left-hand side, for example, actually it's not to, it's on. All right? I have a typo here, it's on. So if my object is on the left-hand side, it is moving to the left, then this one is a negative S. Okay? So if I have the object now makes a U-turn and it wants to go back to the original position. Now, even though it is going to the right-hand side, but you still use negative S because it is located on the left-hand side of the object. Okay, on the left-hand side of the object. Same goes to the vertical motion. Now, let's look at what happens in the vertical motion. So now let's say you throw an object. Okay, this is the original position. You throw it up. So now my object reaches its maximum height. So this one, okay, now this is our reference line. So this one, obviously, we are going to have a positive S because it's located above the original position. And then when it drops until here, it is going down. But now it is still located above this dotted line, this horizontal line. It is located above the original position. Therefore, you still use positive S. All right. The moment it passed this dotted line and it moves downwards, then it becomes a negative S. Okay. So when it comes to displacement, the things that we look at is the position of the object. Okay. You look at the position. So if it is on the right, regardless of the directions of motion, then it's going to have a positive sign. Okay. It's going to have a positive. Then if it is on the left, then it will have a negative. It is above, then positive. It is below, then negative. All right, you don't look at the directions of motion. That's why I say you don't look at the diagram just now. Diagram just now, it gives you directions of motion, okay, in which this is not useful in our case because we need to take into consideration the sign for three different items, S, V, and A. Now, let's look at velocity. So velocity, now you look at motion, okay, the directions of motion. So let's go back to the diagram of the car. So diagram of the car, initially, okay, I have a diagram here, okay, at its original position. So now it goes to the right-hand side. So at this first position, because my object is heading to the right, it's going to the right-hand side. So you have positive V, okay? And then at the second positions here, now my object makes a U-turn. So even though it still have a positive S, but because the direction of motion is going to the right, to the left-hand side, now you have a negative V. Okay, just now positive V. Now I'm going to write it to make it easier to read. So just now we have a positive V. Now we have a negative V. Okay, negative V, because now it's going to the left. So S depends on the position. V depends on the directions of motion. Okay, so let's look at positions number 3. Okay, positions number 3. Positions number 3, my S is negative S, and it's going to the left. Therefore, I have negative V. And yet position number 4, because now it's going to the right, even though S is negative, now you have positive V. Okay, so that is how you check. That is how you determine the sign convention for each of them. Okay, for each of them. Then how about ball? Okay, this vertical motion. So if I throw it up, this one, because it's going up, therefore it has a positive V. Okay, it has a positive V. And then the second position, because now it's going down, even though it's still above the original position, but now we have a negative V because it's going down, right? Because it's going down. And then number 3, okay, this negative S, and it's going down, therefore I have negative V. So that is how you determine sign convention for each of them. Okay, for each of them. All right, next. Okay, so when it comes to acceleration, so acceleration is a bit hard to say. It depends on what. Okay, because like I told you before, you have to look at what happens to its velocity, whether it's accelerate or decelerate, and then you have to look at its directions of motion. But in general, in your syllabus, okay, we make it simple. Okay, we only look at one of an item. Okay, we don't think whether it's a accelerator and going to the left and right at the same time. Okay, we don't look at both items at the same time. Usually for horizontal motion, we just see whether it's accelerate or decelerate. Usually, okay, usually. So if it's accelerate, then we say it's positive. If it is decelerate, then we say it's negative. For vertical motion, when it comes to free fall motion, then it is always negative. Okay, or slowing down. Okay, free fall. So even if moving upwards, so you always have a negative value. Okay, even if it's going up, then it slows down. But if it drops, then it's getting faster in the negative direction. Therefore, vertical motion, you look at both. But because we use the term free fall, so we know it's always negative. Okay, so it's slowing down even if it's moving upwards. Okay, and then for vertical motion, it is positive if you have a external force. For example, like the examples that I gave you just now, burning fuel. Okay, rocket move up because you burn fuel inside it. Okay, so it move up with an increasing velocity because you launch it. It start from 0 velocity and then it move up. Therefore, you have a positive A. Okay, you have a positive acceleration. If it's moving with decreasing velocity, then of course you are going to have a negative sign. Okay, so you look at whether it's a increasing velocity, it's a speed up, or it's slowing down. Okay, it's speed up or slowing down. In your syllabus, most of the times, we assume A equals to negative G. Okay, because we just look at free fall situation. Okay, free fall. I think only once in your past exam, you have to use positive A because of a launching rocket, if I'm not mistaken. Okay, I have to check back your past year. But most of the time, we just use A equals to negative G. All right, only if you have external force that causes the object to move upwards, then you have to think that, whether you have to use positive or negative. Otherwise, most of the time, okay, we assume object undergoes free fall motion. Okay, so this table so far, any question? The sign convention is very important here because these 3 quantity, they are vector. If you got the sign wrong, then your final answer is definitely wrong. Even though your final answer may be just a lack of 1 negative, it's still considered as wrong because you are dealing with a vector. Okay, so any questions before I proceed to the next part? Kalau ada soalan boleh tanya. Okay, kalau ada soalan boleh tanya. 3, 2, 1, no question, good. Now we go to the next one. So next one is the keywords. Okay, so I have take out some keywords, okay, that you will see very often in the questions. And when you look at all these things, you have to understand the hidden meaning. Okay, the hidden meaning. So what does it mean by hidden meaning? So the first one is when the question say uniform. Okay, so it means constant and it means same. All three of them, they carry same meaning, especially when the questions mention constant velocity. Okay, if the questions mentions constant velocity, then the hidden information is A equals to 0. So you yourself should know A is equals to 0. Question won't tell you. Okay, questions won't tell you, oh, now you have A equals to 0 and your object moving with constant velocity. No, it won't happen. Okay, it will just tell you, okay, now a car is moving with constant velocity, and then what happened? Okay, it won't tell you A equals to 0. So this is what I call hidden information based on the keywords given. And then the second thing, increasing velocity or speed up. It means you have positive A. Okay, A is positive. If the question tells you decreasing velocity or slowing down, then it means you have negative value of acceleration, which is negative A. All right. And then a zero velocity, or most of the time, the question will just tell you object is at stationary or at rest. Okay, stationary or at rest, it just tells you velocity is equals to 0. So usually is u equals to 0 or v equals to 0. Okay, so come to rest. Come to rest means final velocity is equals to 0. Or initially the object is at rest, then it's speed up. Okay, then in that case, you know u is equals to 0. Okay, so at rest, this term rest, you will see it very, very often in question. So it carries a hidden meaning where velocity is equals to 0, either the initial or either the final velocity. Okay, so if you have a negative velocity, then the object is moving in the opposite direction. Now, this negative velocity, you yourself have to take note. Okay, because sometimes questions will tell you like this. Now, you have two objects coming from an opposite side, opposite direction. So you have a car moving towards the other car, and the other car is moving towards the original one. Okay, so they are moving towards each other. So in this case, you will have one positive velocity and one negative velocity because the second car is moving in the opposite direction. Okay, first car, second car. So one positive, one negative. So if you have two objects moving in the opposite direction, one object must have negative value. Okay, one of them must have a negative value. So next one is the uniform velocity. So I mentioned it before, you have a zero acceleration. So negative acceleration, now this is a new term, okay, retardation. Some of you might have seen it in your secondary school, and then some of you might have never seen this term before. So retardation means deceleration. Okay, object slows down. So it has two meanings, okay, negative accelerations, decelerations, or accelerate in the opposite direction. So either one, okay, so most of the time we just look at whether it accelerate or decelerate most of the time. Okay, unless you cannot determine the sign convention based on accelerate or decelerate, then you look at the direction. Okay, so all these terms, they carry hidden meaning in question. Question won't tell you what is the value, what is the sign convention, but you yourself have to know based on the terms given. Okay, based on the terms given. So if questions mentions deceleration or retardation, then it is negative A. Okay, it is negative A. So this is just a diagram. Okay, so this one we discussed it already. Now let's go back to your notes. So the sign conventions, bullet point D, you just cancel it out. You look at my notes. Okay, the notes that I give you in the Telegram, the slide the PDF that I posted in Telegram yesterday. Okay, together with the graph, this one. So yesterday I posted the PDF. Actually, it's a 2 pages PDF. One for the graph and one for this sign convention. Okay, so next. So now let's look at the different situations. Okay, sometimes a words makes different. Okay, a single terms makes different. For example, now you have a case as shown in this diagram. You carry an object, a ball, and then you have to read the questions carefully. Look for the important terms. Okay, the important terms here is drop or thrown. If you drop something, okay, then you just hold it and then you open your palms, you open your hand and let it drop, in which it means initial velocity is 0. 0 ms -1. Okay, the highlight term in my notes is the values that you should know even before you start answering the questions. Okay, the information that you should know before you answer the question. So if you drop something, then u is equals to 0. If you thrown something, then u is an unknown, okay, because it is not equals to 0. Okay, drop equals to 0, thrown initial velocity is not equals to 0. Now, how about acceleration? Well, just now I told you, the moment an object leaves your hands and there's no external force acting on the object, no other external force, then the object is being considered as free fall. So in this case, we can always say A equals to negative 9.81 ms negative 2. Okay, A equals to negative 9.81 ms negative 2. As you can see here, I don't use G. All right, I don't use G in finding the value, okay, in listing out the information. That's why I don't encourage you to use equations that are coming with G, because it will make you confused. So a very often seen mistake, for example, just now we have V equals to U minus GT. All right, whenever students use this information, these equations, the mistake that they did, they often substitute G as a negative 9.81. Okay, they often substitute it as a negative 9.81 T. So this is wrong because you already changed the equations to negative. You already changed it into negative, so you don't add this negative anymore. All right. So that's why I always encourage my students to stick to the original equation, which is V equals to U plus AT. And then what we do, we memorize this one. A always equals to negative 9.81. Then you won't get confused. Okay, you won't use the wrong equation. So you can substitute V equals to U plus negative 9.81 T. Then this is correct. Okay, so this is just from my opinion. If you think, okay, you like this equation very much, you can do it very well, you won't make any mistake, go ahead. All right, in my class, I won't force you to follow my method. I won't force you to follow my step. As long as you got the correct answer, then that is fine. Okay, because physics, you can solve it in a multiple way with with different method. So it is up to you which method you want to use. I can only give you my opinion based on my experience. All right, so whether you want to follow or not, it's totally up to you. All right. So don't go out and say, okay, my lecturer tell me I must use this method. No, there is no such thing. Okay, I just suggest you to stick to just one equation. So if you want to use the other one, go ahead. So now let's go back to the tables. An object is thrown from a certain height. So thrown, we don't know the value, but the moment you throw an object, it leaves your hand as well. Therefore, we have negative 9.81 ms negative 2. Okay, negative 9.81 ms negative 2. So V, we don't know the value, okay, because the moment it leaves your hand, you don't know what happens to its final velocity until you calculate it, right? And then how about S? Now S, the moment you leave this object, if you look at this diagram, the original position is here. Okay, this is the original position. Or I call it reference line, okay, reference position. Okay, reference position. So either you call it original positions or you call it reference position. Now, the moment you drop this object or you throw it downwards, then the object is going to below the original position. In that case, this H is actually a negative value. So negative H. Okay, in both example, negative H. So the main difference is the initial velocity. Okay, one you know is 0 because you drop something. Another one is non-zero because you throw something with an initial speed. So when you throw, means object is moving with initial speed, initial velocity. Okay, it's moving with initial velocity. All right. So that is the main difference between two of them. So the time also is an unknown. So the known value is U, A, and S. You know what happened to these three variables based on the motion based on the situations given. Okay, let's look at the second example. Okay. All right. Okay, the first one. Now you throw an object upwards. Okay, you thrown it up, and then what happened in the case? Okay, in this question, if your object has already reached the highest point. So now this one, the information that we want to find is what happened at the highest position. Okay, highest position. So you don't look at what happens in between the original position and the highest position. Okay, we're just going to look at what happened at the highest point. So your object now is the ball. So we are going to take here as our reference position. Okay, our reference position. So reference. So when you throw it upwards, okay, what happens to its initial velocity? You don't know because you thrown it up. So when you throw something, okay, you throw something, it's moving with an initial velocity. Okay, so the only information that we know is v is not equal to 0 because you throw it up. Okay, and then what happens to v? Now you try to imagine what happens to something at its highest point. Now can anyone tell me what happens to an object when it reaches its maximum position, its highest point?
Stop.
It's stop. Okay, so the moment it stops, then we say the velocity at the highest point is equals to 0. So if you're looking at highest point, then we can say v is equals to 0. Okay, so u is not 0, but v is 0. All right, u is not 0, but now it's a positive u. But v, when it reaches the highest point, it stops for a moment before it drops. Therefore, we say v equals to 0. Okay, v equals to 0. So this one is from here going up to maximum height. And then A, now again, you throw something. The moment it leaves your hand, A is always equals to negative 9.81 ms negative 2. Okay, even though it's moving up, but now it's decreasing velocity. Okay, it moved up with decreasing velocity, therefore it's decelerate. So we still use negative 9.81. Okay, we use negative 9.81 because it's slowing down. And that's why when it reaches highest point, velocity is equal to 0. S, now what happens to the S? So you throw something up, object is moving towards a position that is above our reference position. Therefore, we have positive h. Okay, let's assume this is h. So we have a positive h. So again, time is an unknown. Okay, time is an unknown. So now what I want you to do, I want you to create another set of value. We are going to see what happened. Okay, what happened when it drops. Okay, so just now we say it goes to the highest point. What happened if the object drops? Okay, in the same motion. Okay, you throw it up and then it drops again. Okay, it drops. So if it drops, then we are going to take highest point as our initial position. So for this one complete motion, actually you can split into two. Okay, the moment your object changes its direction, then you can treat it as another set of motion. Okay, kamu boleh anggap dia sebagai dua motion. Okay, pada masa yang dia ubah arah. So initially dia go up, kamu anggap itu sebagai satu motion. When it reaches highest point dan dia jatuh, then you assume that is the second motion. So kamu boleh pecahkan dia menjadi dua set motion and then guna dua set equations untuk selesaikan dia. Alright. So just now we have ball as initial position. Now what happened if you are going to assume your object dropped from highest point? Then we are going to take here as initial velocity. So this is your initial position. Okay, this is your initial position. In this case, we say u equals to 0. All right. So u equals to 0. And then what happens to the h then? Now, if you are going to take highest point as your initial position, then our reference line is now here. Okay, so this will be our reference line. So even though you throw the object from a ball from this red color reference line, the moment it reaches highest point and you're going to take highest point as your reference position, then our S will now become a negative H. Okay, will be a negative H. And then A is always negative 9.81. MS negative 2. So if you split it into two different motion, going up as one set of motion and then going down as the other set of motion, then you have to make sure you use correct sign. Okay, you have to make sure you use the correct sign for each of them. And your V is definitely a negative value. Okay, a negative value because now it's going down. Okay, so that this is how you solve the questions, right? Involve going up and then going down. All right, so you throw something up, definitely it will drop. So if it drops, then you have to assume, you have to take another set of information. Okay, so our highest point is now our reference position. So reference point, reference line is up to you to choose. Okay, if you want to take highest point as a reference line, go ahead. Okay, nothing's wrong with it. Just have to make sure you use the correct sign. Okay, kamu adalah orang yang menentukan di manakah reference line itu. Kamu nak ambil bola kah, nak ambil highest point kah, semua boleh, tak ada masalah. Okay, it is totally up to you. So nothing's wrong with the reference line. Okay, you are the one that determine where you want to use. Just make sure you use the correct sign. If a sign is wrong, then everything will be wrong. Okay, so next one. Next one, we look at the middle one. Okay, now the middle one, you throw it up and it falls down. Okay, now it's a complete motion. Okay, so just now I split it into two different set of motion. What if now I don't want to split it? Okay, just now I take highest point as reference line for the falling down motion. Now, what if I don't want to take a reference line at the highest point? I want to take just one reference line here. Okay, so this is our reference line. So the reference position is here. Now you thrown something up, your U is definitely a positive value. Okay, because you thrown it up. And then what happens to V? When it drops back to the line, to the reference line. So what we are looking at here, this is our initial position. Okay, this whole diagram, we are just looking at two positions. This is our final position. They are all on the same reference line. Okay, so when you throw up, your U is positive. And when it drops back to the same reference line, to the same height, then it is a negative value and the value would be same as U. Because your object undergoes free fall, no external force. All right, therefore, when it drops back to the same reference line, it will have the same initial velocity. Okay, same magnitude as the initial velocity. Just that now you have a negative sign here. So initially you have a positive U, and then at its final position you have negative U. Acceleration is still the same, negative 9.81. Okay, negative 9.81, ms negative 2 at its final position. Okay, at this final position. So the information that we listed out is for the final position. Okay, it's for the final position. And then the S, what happens to S? Now it goes up and then it drops back to the same reference line. Therefore, S is equal to 0. Okay, 0 meter. And then the time is an unknown. Okay, so maybe the questions will give you. It all depends on the questions. All right, so that is done for the second diagram. Now let's look at the last diagram. So last diagram, what happens here? Okay, now you have an object. This is your initial position. Okay, initial position. And then now this is your final position. Okay, and then this is the reference line. No, not this one, sorry. So reference line should be start from the object. So your initial position is here. Okay, so this is your reference line. Okay, so from here to here is a H. Okay, let's call it h. So initial velocity, you throw it up, so you have a positive value. That is what we know. Final velocity, okay, you have a negative value because it's going down. And then how about A? Like I told you, okay, when it is moving with a free fall motions, it's always negative 9.81, ms negative 2, and then the s. Now, if you look at what happens to the diagram, the final object, the final position is below reference line. Okay, so even though you throw it up, and then now it's below reference line, so we have negative h. Okay, negative h. You don't think about the highest point. Okay, it has nothing to do with highest point now. What are we going to look at? It's just a relationship between initial and final. Remember, what is the definitions of a displacement? Displacement is the shortest distance between initial and final. So you don't have to think what is the h here. Okay, let's say this is small letter h. So you don't have to think what happens to this small letter h. It has nothing to do with our final positions now. Okay, our final positions, we just have to look at the capital letter h. So capital letter h is negative value because your object is located below reference line. And the reasons why we don't look at the small letter h, because our displacement tells us we don't have to take it into considerations. We don't have to look at it. Okay, we just look at what happens between initial and final. So between initial and final, the shortest distance is capital letter h. All right, and then the t again is an unknown. So that's it. Okay, that is a various possible situation, various possible cases in a free fall motion. All right, so now it seems like it is a projectile motion, but in this case, we often assume it is a free fall. It is just a vertical motion. Okay, unless the question tells you now you throw something at an angle, then we look at it as a projectile motion. All right, so far, any questions regarding these three given cases, these three given situation? Ada sebarang pertanyaan berkaitan dengan tiga case ini? So these three cases, you must know how to solve it, yeah, because it's very, very important, especially what happens at the various position. And you're going to apply these three in a projectile motion as well. All right, you're going to apply these three concepts, these three situations in your projectile motion. So right now, we are still at a vertical motion. Okay, kita masih di vertical motion lagi. So ada apa-apa pertanyaan berkaitan dengan vertical motion?
Madam,
Yes?
Okay, so for v equals to negative u, in a sense, can we just write this equation down and then we don't really have to calculate?
Of course you can. Because
okay,
this is considered as a concept. So if you can write v equals to negative u, then actually you score a k1 here already.
Oh, all right. Okay, thank you, madam.
Okay. So tadi ada seorang lagi siapa?
Madam nak tengok atas lagi boleh tak? Nak tengok balik sekejap.
Tengok balik RM10 nak.
Okay, thank you madam.
All right. So so we are done with a vertical motion. So next. Okay, next we are going to see projectile motion. Okay, projectile motion. Yeah. Okay, projectile motion. So projectile motion is an object that is being launched at an angle, either 0 degree or a non-zero value, but it's definitely less than 90 degree. Okay, so if an angle is equals to 0 degree, sometimes the question will mention it as horizontal projectile motion. Okay. Horizontal projectile motion. So if it is 90 degree, then that is free fall motion. So if the angle is in between 0 degree and then it is less than 90 degree, then we just call it projectile motion. And that is what we call is being launched at an angle. Okay, so if theta is equals to 90 degree, then we say it's free fall motion. So projectile motion is a motion of an object through air resistance in 2D. So we are looking at 2 dimensions now, and it's under the influence of gravity. Okay, it moves solely under the influence of gravity. So what does it mean? it means we ignore the air resistance. Okay, we ignore the air resistance. So a projectile motion consists of two components. Right, so you have to look at it in terms of a x component and also y component, and there are an assumption that is being made in each component. So for x component, we assume motion moving with a constant velocity. Okay, because of what? Because we ignore air resistance. So in that case, if it is moving with constant velocity, so this is what I told you just now. What happened if the questions mentions constant velocity? We have A equals to 0, right? So you just sub A equals to 0 in your equations. So now when it comes to y component, we say motion is moving under gravitational acceleration. So your A along y component is equals to negative g, okay, which is also equals to negative 9.81 ms negative 2. So when it comes to the projectile motions, you have to split it into x and y component. Why x and y component? Now let's look at the diagram here. Okay, so the reasons why we are going to look at it in terms of a two component, it is because, okay, now for a projectile motion, okay, the motions, we often take the tangent of the curve. Okay, so when you look at the tangents of the curve, you look at this u, you look at this v1, this v, v2. Now, it's moving in between x and y component. It is moving at an angle. Therefore, you need to split them. You need to resolve it into x and y component. All right, so for a projectile motion, okay, this is a projectile motion. The directions of motion actually is the tangent of the curve. So tangents of the curve, it comes with an angle. Okay, tangents of the curve. So tangents of the curve, tangents of the curve. So this is our v, 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 and v. So every motion, you have to resolve it into x and y component. All right, because you cannot simply calculate something if they're moving in a 2D motion. Okay, they have an angle. Okay, they're moving with an angle. You cannot simply add them up. You cannot simply solve them. Okay, you can only apply the equations of linear motion if they are all lying on the same component. All right, so let's look at the diagram here. So there are three common cases that will be discussed in this subtopic. The first one is the horizontal projectile motion, where you launch the object at 0 degree. Now, if you launch an object at 0 degree, okay, what happens at the initial point? Even if you split it into x and y component, now what you observe is initial velocity is located on the x component. Okay, it's lying on the x component. Therefore, when it comes to this horizontal projectile motion, the initial velocity, it actually represents your velocity along x component. So ux is equals to u. Okay, ux is equals to u. And then uy, then what happens to uy? So since your resultant vector u, your initial velocity is lying on the x component, it means the y component is equals to 0. Okay, 0 ms negative 1. Now, how about Vx? So, for example, if the question asks you to calculate V here. Okay, now this is your V. Okay, now let's say the question asks you to calculate the V. Okay, now I'm not going to take this. I forgot about something. Okay, now let's say your V is here. Okay, so this V, it has an angle. Okay, this V, it has an angle. Okay, now it looks nice. So this is your V. So this V is moving with an angle. So what are you going to do? Again, you need to resolve it into x and y component. Okay, so this is your Vx, this is your Vy. All right, because now it has an angle. So you cannot just use V in your calculation. You have to split it into x component and also y component for every single set of variable. Now, do we have the values of the Vx? Actually, we do. We have to go back to the assumption. Assumption tells us that for x component, your object is moving with constant velocity. So x component, constant velocity. Okay, constant velocity for the x component, and then constant acceleration for the y component. Constant acceleration. Yeah. Okay. So constant accelerations for the y component. So now, why is it so important to know whether it's constant velocity or constant acceleration? Now, constant velocity, why is it so important? It tells us there's no acceleration. Now, what does it mean by no accelerations? So again, no accelerations, constant velocity, the information that we get is actually initial is equals to final. Therefore, our Vx is actually equals to Ux. And when it comes to horizontal projectile motion, it is actually equals to your U. Okay, it is actually equals to your U. Why? Because x component, we assume Ax equals to 0. So Ax equals to 0, V equals to U. That is very important. Okay, so constant velocity, it tells us Vx equals to Ux. So for x component, the moment you obtain the value for x Ux, then it means you have Vx as well. Alright, kalau kamu dapat Ux sahaja, dia bermaksud kamu ada Vx juga sebab constant velocity. Then as x is just the range, okay, it's your R. So the time is still an unknown because we don't have the values yet. Right? So there's something missing in the diagram. So this one is your h, the height. So Uy is equals to 0, Vy, we don't have any information. Why? Because now your object is moving with constant acceleration. You have A. Your A is now equals to negative G, which is equals to negative 9.81 ms negative 2. So how are we going to calculate Vy then? So in order to calculate Vy, we need to go back to that 4 equation, okay, which is V equals to U plus AT, V square equals to U square plus 2AS, S equals to 1 over 2U plus VT, and S equals to UT plus 1 over 2AT squared. So you need to apply these 4 equations to calculate the values for AY and also SY. But in this case, you have to take note. If you look at the diagram, when you have a horizontal projectile motion, H is located below your reference line. Okay, therefore it is a negative value, negative H. So when you calculate the values of SY, you should obtain a negative value. Or if you are given the value, then you sub it as a negative value. All right, negative H. So this is for horizontal projectile motion. Okay. So for constant velocity, which equations are we going to use? We don't use this 4 equation. Okay, we don't use this 4 equation. This 4 is only for constant acceleration. When it comes to constant velocity, okay, you can straight away use S equals to UT. So this is for constant velocity. Okay, S equals to UT. So how do I know S equals to UT? Actually, you can use this 4 equation. You sub A equals to 0. So this is what you're going to get, S equals to UT. So actually, it's very simple. X component, you have only 1 equation. Y component, you have 4 equation. Okay, kamu boleh catat lah ini benda ini actually is quite useful. Right, you know you have only 1 equation for the X component, then you know what is the information that can be found along the X component. Okay, now let's look at the second diagram. Okay, the second cases. So it's going to take up more than 1 hour, sorry. So if you have anything to do, you may leave the class. Okay, this is not a compulsory class. So after this, I will post the videos in the YouTube as well, yeah. So if you want to follow us until the end, I think just 1 more cases. Yeah, just 1 more cases, then we finish already. Right, so if you want to follow until the end, of course, that would be good. If you have something to do, then you may leave the class. Okay, it's going to take up more than 1 hour. So now, angle launch on the level's ground. So you have an angle, and this angle is from the ground. All right, this is the angle, theta. So now you launch something at an angle. So like I told you just now, whenever you launch something at an angle, to make it easier, we are going to resolve it into X and Y component. Okay, we are going to resolve it into X and Y component. So we need a Ux. So this is your Ux. And then this is your Uy. All right. ux and uy. So now you have a case that looks like this. So this is some things that we have seen previously. So this is your u, this is your ux, this is your uy, this is the angle. So what can we say about ux and uy? By using trigo functions, we know that uy is equals to u. Now, because the angle is located beside x component, we use uy equals to u sine theta. And then ux equals to u cos theta. All right, this is the things that we learned in chapter 1. So if you are given the angle beside y component, then it will be different. So if this is your uy, this is your ux, and this is the u, and that angles given is here. Then what will happen is that you are going to use uy equals to u cos theta, and then ux equals to u sine theta. All right. So in this example, I'm going to assume my angle is beside x component. All right. So I'm going to use this case. So when it comes to questions, you have to read carefully, see where is the angle. So my ux is now u cos theta, and then uy is u sine theta. So again, just now we say x component, okay, for our x component, object is moving with constant velocity. Therefore, Vx is also equals to u cos theta. Okay, it's also equals to u cos theta. Now, the values that I know even before I solve the question is the ax. Okay, so ax is always equals to 0 because of this constant velocity. So ms negative 2. Sx, well, it's just a range, so I have r. And then the time depends on the question, see whether it's given or not. How about the y component? So y component, again, u is equals to u sine theta. Vy is an unknown, where you have to calculate by using these 4 equations. Okay, and then ay, again, the moment you throw something, okay, the moment you throw it up, then it undergoes free fall. So you have a negative 9.81 ms negative 2. How about sy now? So this sy, it depends on the positions that you are looking at. So for example, now I take sy as here. Okay, I take this as my final position. So if my final position is, then sy is 0. Why? Because it goes up to maximum and then it drops back to the ground. Okay, it drops back to the ground. So now it goes back to my reference line. So the ground is now reference line and it drops back, it goes back to the ground. Therefore, my sy is equals to 0. Okay, my sy is equals to 0. And then t again is an unknown. Right? T is an unknown. Now, another case that the questions that lie to us is what happened at maximum height. So what happened at maximum height? Now it assumes your object is here. Okay, this is your maximum height. So this would be the height, the h. So at maximum height, okay, at maximum height, our object is moving along the x component. Okay, because we say the motion is the tangents of the curve. So in this case, this is the directions of motion. Okay, the directions of motion, which also represents the directions of velocity. So now my velocity, my motion is lying on the x component only. All right, it's lying on the x component. So ux, we have u cos theta already. How about vx? Now, because my object is lying on the x component, therefore, my ux is a non-zero value, is u cos theta. But now my vx is equals to 0. Okay, my vy. So this is uy. So vy is equals to, this is vx. This is vy. So vx is equals to u cos theta. Vy is equals to 0 because of the motion. Okay, the directions of motion is now lying on the x component. So vy is 0. So at maximum height, we say vy is equals to 0 ms negative 1. Okay, but your Vx is a non-zero value. Okay, your Vx is non-zero. Vx is not zero. Vx is equals to u cos theta. So this is only for maximum height. Okay, for maximum height. How about Sy? So Sy now, because the h is located above the ground, therefore it's positive h. Okay, therefore it's positive h. So how about T2? Now this projectile motion is something quite we say quite special. Okay, because the diagram is symmetry. Okay, what does it mean by symmetry? It means the left hand side is equals to the right hand side if you flip it. Okay, they have the same shape, they have the same times, everything is the same for the x component and the y component. So when it comes to the maximum height, what can I say about the range? Okay, the range is half of the r. Okay, so for at maximum height, okay, I'm going to add more information here ya, yang tak ada dalam nota anda punya. So for a maximum height, what am I going to do? I have Sx equals to half r. Okay, half of the range because they are symmetry. So the time taken, the distance traveled by the object from initial to the maximum height and from maximum height until it goes back to the ground, that is the condition. Okay, it goes back to the ground, it's the same. Okay, if you start from ground and goes back to the ground, then the time taken from initial to maximum height and from maximum height to final, they are the same. And the distance travel, the horizontal distance travel from initial to maximum height and from maximum height to the ground, they are also the same. So at maximum height, your Sx is half of the range, half r. Okay, and then your time taken is half of the T1. Okay, half of the T1. So T1 is the time taken until it reaches your final position. T2 is the time taken until it reaches maximum height. So it takes half of the time to reach the ground. All right, to reach the maximum height. So T1 is the time taken to goes back to ground. T2 equals to half T1, which is equals to the time taken to reach maximum height. So these are some of the important information. Okay, some of the important informations that you need to write down. So initial or your original notes, they don't include the x component, but I think it's very important for you to understand all these things. All right, so make sure you write it down. So make sure you know how to calculate the information for the x component, how to calculate the information for the y component. X component, constant velocity, y component, constant acceleration. X component, you can use s equals to ut to find all the information. Y component, you need to apply this for equation. Right? And then always resolve it into x and y component. Any information, you resolve it into x and y component. All right. Angle launched from a certain height. Okay, how are we going to do these questions then? How are we going to solve these questions? Now you have a case where now the object is not going back to its original position. Okay, so what happened here is now it goes further down. So your reference line is here. Okay, so this is your reference line. A reference line, reference position. So now you launch it up, you launch it at an angle theta. So u, the initial velocity, once again, is lying between x and y component. It's not lying on the x component, it's not lying on the y component. So what are we going to do? We are going to resolve it. So you need ux here, and then you have a uy here. Okay, so ux once again is a u cos theta, and then uy is a u sine theta. Okay, uy is a u sine theta. And then how about vx? Again, for x component, we say object is moving with constant velocity. So Vx is also equals to u cos theta. Vy is an unknown, where you have to solve it by using the 4 linear equation. Okay, 4 linear equations. And then Ax, well, Ax and Ay you don't even have to calculate. It's fixed in projectile motion. Ax is always equals to 0. And then Ay is always equals to negative 9.81. Okay, 9.81. Okay, 9.81. And then Sx. So now my final position is here. Okay, this is final. So my Sx is the whole range. All right, it's this one. So this is my range, which is R. So my Sx is now R. So this one you have to calculate it. Okay, you have to calculate it by using ut, u times t. So t is an unknown. All right, t is an unknown. How about sy? So sy, okay, now I have a table with a height h. If you look at the final position and the initial position is on the table, final position is on the ground. Okay, and this final position is located below the original position. Therefore, your sy should be a negative value, negative h. So again, t1 is an unknown. All right, t1 is an unknown. Okay, so now how about my... yes?
Negative H or okay.
Negative h sebab dia di bawah meja, your
Tak,
final
dekat
position.
aku, dekat nota H besar. Apa?
Besar? Ada h besar ada bagi? Ada kan? Okay, now at the maximum height, okay, at maximum height, so this is our maximum height. Okay, so this is maximum height. So maximum height, I'm going to use a capital letter H. Right? So Vy, now, what happened at maximum height? Again, our motion is the tangent to the curve. So this is the directions of motion. Okay, this is the directions of motion. So if you resolve it into x and y component, what happens again? It tells you your Vy is equals to 0. Okay, at the maximum height, the velocity, they are all lying on the x component. So Vy equals to 0. And now the Sy is a positive H, positive capital letter H, because now at maximum height is located above the reference line. Okay, so the reference line is very important for you to determine whether your S is positive or negative. Now, how about T2? T2 is an unknown. Okay, and now in this case, you cannot say T2 is equals to half T1 anymore. Okay, T2 is no longer equals to half T1. Why? Because now this is not a symmetrical projectile motion. All right. If the final position is here, is on the reference line, then yes, you can say T2 is half T1. But now because it's further down, okay, if it's further down, so T1 is the time taken to reach the ground, and now the diagram is no longer symmetry. Therefore, we cannot say T2 is equals to half T1. All right. You also cannot say Sx equals to half R. This is not valid anymore. All right. So this is only valid if you have a diagram like this, where they are symmetry. Okay, where it starts from ground and then it goes back to the ground. All right. This one is only valid if you have a symmetry diagram. Okay, if the projectile motion is symmetry. So if it is not symmetry, then this one is no longer valid. Okay, so it is very important. Okay, that's why your notes, they give you 3 different cases. They want you to understand what happened in every situation. Okay, now to solve the problems of projectile motions, okay, we treat the horizontals and the vertical components separately. So this is very important. Okay, you treat them separately because you cannot solve vector if they are lying on the difference component. All right, if they are lying on the different component, you cannot solve it. So how are we going to solve the questions? So I'm going to give you some additional notes. Actually, I gave you before. For x component, you have only one equation, which is Sx equals to uxt. Okay, so for y component, you use that 4 equation. Okay, you use Vy equals to uy u plus ayt. Vy square equals to u square plus 2as. And then s equals to 1 over 2 u plus vt. Now, if you notice, I put subscript in all of them. okay, in all of them, because you can only use the information from the y component to find another information along the y component. All right, you cannot use information from x component to find the information for y component. That would be wrong. And then the last equation is s equals to ut plus 1 over 2 at squared. So for x component, actually this one they give you the equations already, but I simplified it u. X component, we use this set. Y component, actually you have just one equation. All right, you have just one equations. So for x component, your ux is equals to vx. That is the information that we have. Okay, and then now I'm just going to change it a bit. Your notes, they give you the same thing. They give you vx. All right. Now, so from these equations, actually it's simplified from this equation. Your a equals to 0. Okay, for x component, a equals to 0. So you simplify the equations, you got vx equals to ux. So the second equation is also vx equals to ux, okay, because a equals to 0. The third equations, you got xx equals to uxt. And then the last equations, what do you get? You got sx equals to 1 over 2 ux plus vxt. So if you simplify this one, actually you're going to get sx equals to uxt. Okay, so yeah, basically that is what happened. I think you just put this one back in here. Okay, you put this one back in here. Need to change a little bit. Okay, so complete this table. All right, you put it here. So this table, it just tells you what happened if you apply this 4 equation. Okay, this table, it tells you what happens when you apply these 4 equations. So eventually for sx, for x component, you are just going to obtain this one equation. Okay, so y component, you have 4 equations that you have to use, and make sure every one of them come with a subscript. All right, come with a subscript. Okay, so I give you 1 minute to write it down. Okay, this 4 equation, you put it in the table. So just now I misunderstood the table. All right, so my bad. So you put it in the table, sorry. So I give you 1 minute to complete the tables, and then the last page, I just want you to cancel the last page. I will tell you the reasons why I don't want you to follow the equation in the last page. Okay, so I give you 1 minute to complete it. All right. So now let's see. Now this page, actually, I don't encourage my students to memorize it. Okay, that is because there are a few conditions that you need to follow. Okay, especially the motions. Okay, the types of the projectile motions that you're looking at. So in order to apply the equations here, you must have a symmetrical projectile motion. All right, if they are not symmetrical, then you cannot use all these equations. Okay, and all these equations actually is coming from the 4 linear equation. So instead of memorizing additional 1, 2, 3, 4 equations, I would rather you use the 4 equations that we look at just now, we studied just now. Okay, we learned just now. So you can derive the equations from this table. Okay, this table actually is far more than enough for you to solve all types of projectile motion. So this one is just a shortcut. Okay, this one I will call it shortcut. That's why in my class, I always ask my students to cancel this page, because I don't want you to get confused. This is only valid if you have a symmetrical projectile motion. If you have a horizontal projectile motion, then this is invalid. Okay, if you have projectile motions like the one just now, you throw it upwards and then it goes back, then that is not valid. If you have a projectile motions where you are at the ground and then you throw something up, again, it is not valid. Okay, it is not valid. So this one is only valid if you have a symmetrical projectile motion. And that's why I don't like my students to memorize all this, because basically you can solve this, you can derive this 4 equation based on the 4 linear equation in the previous page. Okay, based on this linear equation, this 4. Right, so the last page, you just ignore it. So now I'm going to try one questions with you guys. Okay, if you want to do it with me, of course you can. If you don't want, then that's fine. Okay, if you don't want, then you may leave the class, because actually the questions should be discussed in a tutorial. All right, so I'm just going to do one additional questions with you so that you have an idea on how to solve it. So now let's look at questions number 3. Okay, I'm not sure whether this question is in your notes or not, because this is the questions that I use in my own notes. Okay, in my own tutorial notes. So an object is projected with an initial velocity. Now, initial velocity, this is u. Okay, so it's not ux, it is not uy. At an angle, so now you have an angle to the horizontal, 30 degrees to the horizontal. Assuming that acceleration due to gravity is 9.81, determines the maximum height reached, the times of flight, and the range of the object. So now you have a projectile motion. Okay, this is the diagram. This is an object. It is being projected with an initial velocity u equals to 20 meters per second. And then the angles here, theta is equals to 30 degrees to the horizontal, right? And tells you A is 9.81. Now, how are we going to solve a projectile motion question? Okay, it is always a good idea to draw a table first. Okay, to draw a table. So this is my table. Okay, I'm going to put it here. So this is x component. This is a y component, right? And then I'm going to put my u, v, a, s, t. Okay, put these 5 variables in the equations, in the table. And this is how we extract the information from the question. So look at the questions again. You are given initial velocity u, you are given angle. Okay, and then what else? You are given the gravity. But before we look at the questions again, actually the things that you can fill in the table is the values for acceleration. So A is something special. Okay, you don't even have to read the question. Straight away, you know what is the values that you need to put in the table. So x component, A is 0. And then for the y component, okay, y component is 9.81, negative 9.81. All right, with or without unit is fine in the table. Okay, so table, it doesn't matter, with or without unit is up to you. So A is 0 and negative 9.81. You don't even have to look at the table. Straight away, you know the information already. All right, and then my u. So I have u. Okay, u is equals to u. Okay, ux is equals to 20. 20 cos 30 degree. My uy is a 20 sine 30 degree. Okay, vx, I have it because it's always constant. Okay, so 20 cos 30 degree, vy is an unknown. And then sx and sy, I don't have it, obviously. Why? Because that is being asked in the questions. And times, I also don't have it. So this question actually is quite tricky. Okay, it's split into 2. The first question, questions A, it asks you to calculate until maximum height only. Right, so you have a projectile motion. How are we going to solve questions A? Now it mentions maximum height. The moment questions give you the term maximum height, okay, it tells you your Vy is equals to 0. Just Vy, all right, just Vy. So sometimes the information that you use in the question, it might not be the same as the one in the table. Okay, so you have to read the questions carefully. So Vy is equals to 0 ms negative 1. So you want to calculate maximum height. So you want to calculate Sy. What is the other information that you have? So let's go back to the table. Okay, table tells you that you have Uy. So Uy, you can use it. So Uy is equals to 20 sine 30 degree. Table gives us A. Ay equals to negative 9.81 ms negative 2. Okay, so now you have these 4 variables, then you compare with the 4 equations just now. See which equations contain these 4 variables. Okay, so let's go back to the table. So if you look at this 4 equation, okay, so according to the information just now, we don't have t. So the only equations without t is this one. So which means this is the equations that we are going to use to solve questions A. All right. So we don't have t, we have a v, we have s, we have u, we have a. So we are going to use v square equals to u square plus 2as. So you plug in all of the value and then you calculate s. Okay, you calculate sy. So you try to calculate for me because I don't have the answer with me right now. Okay, so you try to calculate and give me the answer. Okay, kamu cuba kira, tekan and then beritahu saya jawapan. Okay, you can type in the in chat message, in call message, so that I know what is the value. Okay, so who has the value? We got 88 of you. Nobody can give me the answer. $5.1. Okay, I'm going to assume A got different answer. 19.9 got 2 votes. Okay, so 19.9. So you're going to get a positive value, yeah? If you got negative, means something is wrong. So 19.9 meter, because it's above the horizontal line. Okay, now let's look at the second question. So my SY, my maximum height is 19.9 meter. Now, what does it mean by times of flight? So times of flight, it means from the moment from the object leaves the ground until it goes back to the ground. This is the times of flight. Okay, times of flight. So how are we going to solve these questions then if it goes back to the ground? So let's see, do we have enough information along the x component? Obviously, we don't have. Okay, x component, we use s equals to ut. But right now, if you look at the equations, you look at the table, what do I have? I have only u. I don't have s, I don't have t. So it means that I need to use y component to find the time. So let's see, what is the information that I have? So I have uy, again, equals to 20 sine 30 degree. Ay equals to negative 9.81 ms negative 2. And then, since it goes back to the ground, my sy is actually equals to 0 m. Okay, and then I need to find the time. So what is the time taken? So now I have u, I have a, I have s, I have t. So what can I do? I compare with the equations again. So the equations without v is which equations? So equations without v is the last equations here. S equals to ut plus 1 over 2at squared. So this is the equations that I'm going to use to solve questions B. So S equals to ut plus 1 over 2 at squared. So this is method 1. All right, this is method 1. Now, some students, okay, they think they need to use the information from questions A to solve it, which is 19.9 meter. Can or cannot? Yes, you can. So I'm going to show you two methods. Okay, so you can try to see which one is easier for you. So if you want to use the information from questions A, method 2. Okay, method 2. So how are you going to solve it? So you can also use uy equals to 20 sine 30 degree. You can also use ay equals to negative 9.81 ms negative 2. But now you use sy equals to 19.9. Okay, and then you find t. So this t is not the final answer yet. In order to find times of flight, okay, times of flight, because this is just the time taken to reach maximum height. Okay, so this is your diagram. And then the time taken here is just here. From here to here is the t. Okay, this is maximum height. So times of flight is equals to 2t. If you use the information, the sy from from questions A. So if you use sy equals to 0, then you are calculating the information at this point, the final position. So there are two methods that can be used to solve questions B. And both of them, they are correct. Depends on which one, which S you're using. Okay, kamu boleh guna S pada final position, kamu boleh guna S pada maximum height. If you use the S at the maximum height, then the T you have to times 2. All right, because from ground to maximum height is T, from maximum height to ground is another T. So you have 2T. Okay, so just now we have only 1. All right, so you calculate it, you solve it by yourself, and then when you obtain T, you can calculate the range. So range is from a starting point until it goes back to the ground. Okay, so once you have time, means you can apply U equals to S equals to UT. So range is simply means SX equals to UXT. So you can use the time from questions B to calculate it. All right. So that marks the end of this question. I'll leave it to you. You try to calculate and see whether you can get the correct answer or not. Okay, kamu sendiri cuba. Okay, I show you the method. So in my class, most of the time I will just show you the method. All right, so you calculate the answer by yourself. Because I already give you all this information, it shouldn't be an issue for you to find the final answer. All right, so that's all for today. Any questions that you would like to ask before I dismiss the class?
Madam,
Yes?
kan contoh kalau dalam soalan Twitter kan, dia banyak soalan. Macam mana kita nak tahu soalan tu dia macam symmetrical ataupun tak?
Dia terpulang pada soalan. Kalau kamu buang something and it goes back to the ground, then itu symmetrical. As long as dia bermula dan akhir pada paras yang sama, at the same reference line, then that is symmetrical.
Okay, thank you, madam.
So any other questions?
Madam,
Yes?
I just want to know how you get 19.9. I'm not getting the answer.
I don't know. I asked you guys to give me the answer, right? Because I don't have calculator with
Madam,
me.
the value they use, I think they use rad, not degree. So they count different value. That's why I count 5.1 also.
Oh, you
Yeah,
can't
that's why I
find
can't find. I'm finding
Yeah.
I'm getting a different answer.
Okay, then the correct answer should be 5.1. Because right now I don't have my calculator. My calculator is out of battery and all shop, they are not open. So this is 5.1. Then this one you need to change also.
Madam, so the angle we have to use for in the calculator will be the degree, not radian.
Yes, of course. If you look at how I write it as a degree, right? I'm not using radian.
All right, thank you, madam.
All right, so thank you very much for correcting the mistake here. So any other questions?
Madam, can I ask if the ball is thrown downwards and then it's also like at an angle like 30 degrees.
Yes.
Then for the UY, is it negative because it's now heading downwards from the reference line?
Very good questions. Yes, it should be negative if you throw downwards. So sometimes you might have a case like this. Okay, you throw something downwards, and then this is your horizontal line. So this is a 30 degree. So your U now, if you resolve U, then your UX is positive, and your UY is a negative value. Okay, so this is what happened if you throw downwards.
Okay, thank you, madam.
Madam,
Yes.
at maximum height, why is Vy equals to 0?
Because your object stopped for a moment. For anything, now let's say this is a path travel. For anything, they want to change the direction. Okay, you throw something up. Before it changes its direction, definitely it will stop for a moment. And that is the moment that we're looking at. And because the object stopped for a moment before it changes its direction, therefore we say V equals to 0. Right? It definitely have to stop. If it don't stop, then it cannot change direction, right?
Okay.
Right, so any other questions? All right, very good. If no, that's all for today. So thank you for attending the class. You may leave the class now.
Thank you, madam.
Thank you, madam.
Thank you, madam.